Application of right triangles. An angle of elevation is the angle formed by a horizontal line and a line of sight to a point above the line. In the diagram, angle 1 is the angle of elevation from the tower T to the plane P. An angle of depression, on the other hand, is the angle formed by the horizontal line and the line of sight to a point below the line. Angle 2 is the angle of depression from the plane to the tower. Since horizontal lines are parallel, angle 1 is congruent to angle 2 by alternate interior angles theorem. Therefore, the angle of elevation from one point is congruent to the angle of depression from the other point. Then, in this case, angle 1 is equal to angle 2. Let us use this diagram and classify whether it's angle of elevation or angle of depression. Angle 5 is the angle formed by the horizontal line and a line of sight to a point below the line, then it is an angle of depression. Angle 6 is formed by the horizontal line and the line of sight to a point above the line, it is the angle of elevation. Still, the measure of angle 5 equals angle 6. What are we going to do when we try to solve angle of depression or elevation? We have these steps. Draw the triangle. Label the sides from angles view. Identify trigonometric function to use. Set up an equation. Solve for the variable. And if in case you're looking for an angle, use the inverse trigonometric functions. Let us apply it to this example. At a point on the ground 50 feet from the foot of the flagpole, the angle of elevation to the top of the pole is 53 degrees. Find the height of the flagpole. Here is the figure. Acute angle 53 degrees. The height of the pole, which is 50 feet away from that point. We will be using tangent. Why? We have acute angle 53 degrees. We're looking for the opposite side. We are given the adjacent side. So that is tangent 53 degrees equals opposite over adjacent. Tangent 53 degrees equals opposite side is height, substituting it, and the adjacent side is 50 feet. Tangent 53 degrees equals height over 50 feet. Height then equals 50 times tangent 53 degrees. The height of the pole is approximately 66.35 feet. Let us have another example. A 20-foot ladder leans against a wall so that the base of the ladder is 8 feet from the base of the building. What is the angle that does that ladder make with the ground? Here is the figure. What function are we going to use? We are giving adjacent side and the hypotenuse side. So acute angle theta, we will be using cosine theta, which is equal to adjacent over hypotenuse. Cosine theta equals adjacent side is 8. The hypotenuse side is 20. Cosine theta equals 8 over 20. And theta equals inverse cosine of the quotient 8 over 20. Theta then equals approximately 66.42 degrees. Another example. At the circus, a person in the audience watches the high wire routine. A 5-foot, 6-inch tall acrobat is standing on a platform that is 25 feet off the ground. How far is the audience member from the base of the platform? If the angle of elevation from the audience member's line of sight to the top of the acrobat is 27 degrees. Here is the figure. We are using tangent. Tangent 27 degrees equals opposite side over the adjacent side. Tangent 27 degrees equals opposite side measures 30.5 over x. X is equal to 30.5 times tangent 27 degrees. The value of x is approximately 15.54 feet. Another problem. At a diving competition, a 6-foot tall diver stands atop the 32-foot platform. The front edge of the platform projects 5 feet beyond the ends of the pool. The pool itself is 50 feet in length. A camera is set up at the opposite end of the pool, even with the pool's edge. If the camera is angled so that its line of sight extends to the top of the diver's head, what is the camera's angle of elevation to the nearest degree? Here is the figure. Acute angle theta, two sides are given. That is, the side opposite to theta is 38 feet. The side adjacent to theta is 45 feet. What function are we going to use? Opposite over adjacent is tangent theta equals tangent theta equals 38 over 45. Theta equals inverse tangent of 38 over 45, and theta measures approximately 40.18 degrees. 22. Here is another example. A roller coaster car is at one of its highest points. It drops at a 63 degrees angle for 320 feet. How high was the roller coaster car to the nearest foot before it began its fall? Here is the figure. Acute angle 63 degrees. Two sides are given, that is opposite side, which is the height, and the hypotenuse side, which measures 320 feet. What function are we going to use? That is opposite over hypotenuse. That is sine. Sine 63 degrees equals opposite over hypotenuse, and sine 63 degrees equals height over 320. Height is equal to 320 times sine 63 degrees. Approximately, the height is equal to 285 feet. Another problem. The shadow Space Needle casts a 67-meter shadow. If the angle of elevation from the tip of the shadow to the top of the Space Needle is 70 degrees, how tall is the Space Needle? Round your answer to the nearest meter. Here is the figure. We're given the acute angle 70 degrees. Sides given are the height, which is the opposite side, and the adjacent side, which measures 67 meters. What function are we going to use? That is opposite over adjacent. That is tangent. Tangent A equals opposite over adjacent, and tangent 70 degrees equals h over 67. H is equal to 67 times tangent 70 degrees, and the height of the Space Needle is approximately 184 meters. You already know how to solve the right triangle and apply it to real-life problems. You are now ready to answer the exercises. That's all for now. Thank you for watching.